So it says use a tape diagram to calculate the solution of 30 equals 5W. So we're going to create a type diagram with 30. And then since it's equal, we want them to be the same size. And we need to fit 5 W's inside of it. Each W has to be the same amount. So if I split 30 into 5 parts, that means each piece would need to be 6. 6 and 6 make 12, plus 6 makes 18, plus 6 makes 24, plus 6 makes 30. So W has to equal 6. In number 2, it says to solve it algebraically. We have 12 equals x divided by 4. One way that we can undo division is through multiplication. If I want to undo dividing by 4, I have to multiply by 4. But to keep my equation balanced, I have to do the same thing on the other side. A 4 and a 4 divide out. So I am left with x. 4 times 12 makes 48. We can check our work by putting 48 in the x position and seeing if it really does equal 12. Is 48 divided by 4 equal to 12? Yes. Number 3, y divided by 5 equals 15. If we were going to do this algebraically, we could multiply both sides by 5. But we're going to take our answer here, and we're going to take y, and we're going to split it into 5 groups. 1, 2, 3, 4, 5. And when we split it into 5 groups, we have each piece is 15. So altogether, 15 and 15 make 30, and then 30 and 15 make 45, plus 15 more makes 60, plus 15 more makes 75. So y must be 75. Then for number 4. Number 4 says solve it algebraically. I put a line through my z just to make sure it doesn't look too similar to my 2. This is multiplying 18 and z together. So let's think, how could I undo multiplication? Or maybe you can think of it as algebra tiles. When I have all of my variables on one side and all of my number tiles on the other, my last step is to split it or divide it. So we're going to split it into 18 equal parts. 18 divided by 18 is 1. So I just have 1 z remaining. When I divide 72 by 18, I get 4, which means z must be 4. Checking our work, 18 times 4, is that 72? Yes, it is. So z must be 4. 4 makes the number sentence true.